for me, it's one of the most fun days of the year. For you, it's one of those days to look back on when you're old, or you'll say, man, that was a waste of my time. But anyway, this is triangle congruence, guys. Triangle proofs using side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Our EQ, what information about two triangles allows you to conclude that the triangles are congruent. Our learning goal, apply side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg to construct triangles and to solve problems. Prove triangles are congruent by using side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. We're going to talk about triangle rigidity, included angle, and included side. Don't giggle at rigidity.
I thought you said something else.
I know. Come on, guys. Moving on. The property of triangle rigidity gives you a shortcut for proving that two triangles are congruent. It states, here's what you need to make sure, actually you should write down the whole thing, but here's the definition of it. If the side lengths of a triangle are given, the triangle can have only one shape. What? I know, it doesn't make much sense. Guys, if I give you three side lengths, what kind of shape is it? Good call. Oh, done. Let's move on. First thing, side, side, side. What? Didn't we already talk about this? Oh, yeah. Yeah, we did. Except when we talked about side, side, side with similarity, Bev, or Bell, if we're talking about similarity, then side lengths are proportional. Am I talking about similarity here? No. No, I'm talking about what? So side lengths are congruent or the same. Very good, okay? So if I'm using side, side, side congruence theorem, what I'm saying is that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Very straightforward. We're going to have 5 different theorems. First one is side, side, side. Theorems or postulates, okay? I'll fill in this chart along the side here, okay? And you might just want to call these, I don't know, just make you a little list, okay? Your triangle congruence shortcuts. First one, side, side, side. Yeah. All right, so we have side, side, side. All right, 3 sides of one triangle congruent to 3 sides of another triangle. I can prove that the 3 triangles are congruent. Okay, you don't have to write this next part down because you already wrote it down once upon a time. An included angle is an angle formed by 2 adjacent sides of a polygon. I'm going to make this easier for you guys. Okay? Check it out. Angle B, right there, that angle. What sides does it touch? AB, and what else? BC. Correct? So if I was going to use side, angle, side, you got to make sure that your angle is touching the 2 sides. Okay? Everybody with me on that? Okay, I have something else. This part you make sure you write down. Side, angle, side congruent says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. What are the hands for? No. I'll go back later. Alright. Side, angle, side. Notice that the angle touches the 2 sides. Correct? If the angle was up here, I would have angle, side, side, and we know that's a no-no. Right, children?
Yes, sir.
I don't. Angle side side is a no-no, right, children?
I don't know
No.
what side that is.
Yo. next, guys, let's talk about this, because this part, I'm going to have you write down pretty much this whole slide, okay? Oh, am I going to leave it there? Yep. An included side is the common side of two consecutive angles in a polygon. Here is what you need to make sure, what I've underlined and what I'm circling or boxing, okay? In triangle PQR, P to Q, side PQ, the side of the triangle, P to Q, is included between angles P and Q. Think of the sides of the triangles like, I don't know, a road that you have to walk down to get from one angle to another. If I had to go from angle P to Q, I would have to walk down what? This road right here, PQ, right? If you're walking a direct road from P to Q, they consider that included sides. Okay? It's just also, it's the side between the angles. Included sides. So, when I talk about included sides, here's why it is important. The angle side angle postulate says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Right? So I've got side, side, side that we started out with. I've got side, angle, side. And now I have angle, side, angle. Correct? Yes, Mr. House. That's right. Good. Okay. What do you notice about side, side, and angle, side, angle? Oh, good. They both have A's. What else do they have? S's. All right. Perfect. Okay. What else beyond that? What's in the, maybe like, this particular here? Okay. In angle, side, angle, the side, a single side, is included between two congruent angles. In side, angle, side, a single angle is included between two congruent sides. Angle, side, angle, and side, angle, side. Okay? Think about how the word included is used in both of those. Anybody got any questions on this yet? Oh, you will. Oh, yeah. Then just wait. I need a couple more seconds. All right. Good. Finish. I'm good. Well, good, because now you got to talk about this one. Angle, side theorem. If I have two angles and a non-included side of one triangle, and if they are congruent to the corresponding angles and the non-included side of another triangle, then the triangles are congruent. Notice where the side is located. Is it between the angles? No, Junior. It's a non-included side. Does it matter which one? No. It could be this side, HG, or it could be HJ. Correct? It's just got to be a non-included side. Okay? Angle, side. It's got a lot of flexibility. It can go either way. Now, it does still have to go in order, right? 1, 2, non-included side. 1, 2, non-included side. Correct? Right? So if HG was congruent and LM was congruent, that wouldn't work out for us. Okay? It still has to be in order as far as the congruent angles are concerned. But it could be either of the non-included angles. Got one more, guys. Last one. We call this hypotenuse leg. It's a little different. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. What kind of triangles must they be? Right triangles. Okay? I'm only talking about right triangles. Remember that all right triangles have special properties. The longest side, the side that is across from the 90-degree angle, we call that the hypotenuse. The other two sides are called legs. Hypotenuse and legs. Yes, and fourth? Eighth grade. You also learned something called the Pythagorean theorem. Yeah, which all of you guys remember as a squared plus b squared equals c squared, and I'm now going to erase that crappy teaching job. Oh, I'm sorry, it's recorded. Oh well. Okay, and you're now going to learn it as leg squared plus leg squared equals hypotenuse squared. Okay, because a squared, b squared, c squared doesn't mean diddly frickin' crap if you don't know what a, b, and c are. Does it? Good, it doesn't, okay? It doesn't. Right? You got to know what A, B, and C are. So don't teach it that way. Teach it as leg squared plus leg squared equals hypotenuse squared. Because every single time you get a right triangle, you're going to be able to identify the hypotenuse, and then you know where that goes in the formula. But that's next year. Right now, the only thing we got to talk about is hypotenuse and legs. Okay? That's it. The good part is that once I get you done with that particular aspect of it, we'll roll right through Unit 3. Okay? 18-wheeler, here we come trucking along. All right. Notice that hypotenuse leg is the special type. It's so special. It's the special type of shortcut I've got, because it's only true for what triangles? Right triangles. Everybody got me? It's only true for right triangles. Okay? Now, I could use side, 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 angle, side, angle, or angle, angle, side in right triangles as well, but most likely you're just going to be trying to find hypotenuse leg. Okay? All right, good. Any questions so far? Everybody's good so far? Everybody's tired of notes so far?
Yes.
Good. Okay, good. So, what you'll do is, I tell you what, I'll give you about a 3-minute break. Finish up, take about 3 minutes. Moving on real quick. Determine if I can use angle, side angle to prove that the triangles are congruent. Okay? Think about this. Do I have any information here about congruent sides? No. The only thing I can conclude is that these sides are going to be congruent because of the reflexive property, correct? See that? Well, think about this, guys. Would angle, side angle be the appropriate theorem here?
No.
No. What would be the appropriate theorem?
Angle.
Angle,
Side. No, angle.
angle, angle, sides. Angle, angle, side. Hey, listen to this. If I'm using angle, side, angle, the included side must be congruent. Y'all see that? I can't skip around, in other words. If I use angle, side, angle, I've got to have the included side here. So I need either this side or this particular angle to be congruent. All right, which one am I going to use here? I don't know if they're right triangle. Because it says it on the board? Because it says it on the board, yeah. Why is it side, side, side? Because it says so, Mr. Robinson. That's the right answer. Probably not the best. Say it again. Is it on the board too? By the reflexive property, BC is congruent to itself. Right? Now, how many sides do I have congruent in the triangle? 3, right? 1 ticky, 2 ticky, 3 ticky. 1 ticky, 2 ticky, 3 ticky. The 3 tickies get to go to both triangles, right? Okay? Side, side, side. it's still around. It's still a thing. Okay? It won't die. Kind of like Manju. All right, so how about here? What theorem am I going to use? Side angle side. Check it out. Y'all see, hopefully you're starting to get this. BC congruent to itself, right? Starting to get that through reflexive property. Question. If this is true, right? Why am I using side angle side?
Because B is both. It goes to both. The angle B goes to both triangles.
Angle B is included in both triangles. Perfect. Okay. What about the angles themselves? They are what in relationship to the sides? In between or included, right? Y'all see this? I hope you do. AB, and then I get angle B, right? And then after angle B, I go B to C, okay? But don't forget the fact that side angle side, right? The angle is included. Let me test your knowledge. Blue. You tell me if this would be okay. Why not? What would that be? That ain't sides. Well, pretend like the reflexive properties. Separate these two. I tell you what, Blue. You know what? It's a bad question, okay? I'm going to redraw a triangle for you. You ready? That, and that. And then it's separate. Okay? Okay? Just like this. And it's like that right there. What's wrong with this, Baloo? It looks real close, Mr. Hobbs. It's so good, though, but I don't really get it, and I'm not paying attention. That's right, right? Side angle. Side angle. What's side angle spelled backwards, Randy? You can say it and you can giggle. What is it?
What?
Side. Side angle, spelled backwards. Angle, side. Do not fall into the trap. Alright? I know, it's funny and it's cute because you're 16. Alright? I'm 29, it's still fun. Alright, but anyway. Hey, check it out. Guys, a lot of you are going to overlook it, okay? Because you're going to get so used to like, oh yeah, they're going to be congruent. It's got to be angle, side, angle, side angle, side. Yo mama, I don't know, alright? And it's all this stuff. But then you're going to sit here on a problem like this, and you're going to say, angle, side's okay. Nope, not okay, right? It does not prove congruency. This is not congruent, okay? Later in the semester, we'll learn why. It's because the sides opposite congruent angles are proportional to each other, but that's a whole different set of marbles, all right? So we do that part later. But understand this. That angle side in and of itself does not prove congruency, okay? All the things you do up here, don't put ASS, all right? Proofs are still a thing. They're not going anywhere. They will still be around. You will still have some today. Trust your gut. What is the first step of every proof? Just remember that, guys. We're still at that phase. We'll be all right from there. What does anybody? Let me see here. Hey, what you notice about these? Yeah, you, Robinson. What you notice about these triangles? I know, put them on the spot. Put a guy on the spot, and then all of a sudden it's... What do you notice is inside one of the triangles? A what? Which makes them what kind of triangles? Right angles would make what kind of triangles? Hey! Right triangles! The reason I think that's important. Why is the fact that right triangles is important here? What does the star mean? I can use what? Robinson. What can I use? What? Robinson. You wrote it down. Look at your notes, buddy. It's okay. What do we call this thing? Hypotenuse leg. Alright. Hey, check it out, guys. Hypotenuse leg. Right? So what I just did with you is what is good. I promise it's good. Here's why. Next time he gets right triangles, he's going to remember this. Right triangles. Why is that important? Okay, they have hypotenuse. Oh, that's right. I've got a shortcut called hypotenuse leg, right? If the hypotenuse and leg, just a single leg of two right triangles are congruent, then the triangles are congruent. Which legs are going to be congruent? The bases or this one? No. Guys, what property always comes up every time I've got two triangles smushed together sharing a side? The reflexive property always comes up. Hypotenuse, leg. Okay? Any questions on that?
What you said, that if
Okay.
any something or
Alright, check it out. Right triangle, I'll do the whole thing. Right angles and triangles means automatically right triangle. Okay? That's to pop off. When you hear right triangle and you're talking about triangle congruence, you've got a special little sauce here. It's the Friday special. Okay? Hypotenuse leg. Anytime I have congruent hypotenuse and a single congruent leg in two right triangles, those triangles are congruent. Right? Okay? So the end game that we're playing today is what? What are all of these trying to get me? No. What? Congruent what? Yeah. Look at the topic today. You're right. Okay? Triangle proofs, right? Side, angle, side. I added 3 more. Okay? All of those go back to congruent triangles. Okay? That's why we did this lesson today. The whole object of those 5 proofs over there is shortcuts to get triangles congruent. Alright? That's our end goal. I think that's it. Unless I decide to give you more. Nope, that's it. Anybody need any slides?
When you close